Hello everyone, welcome back to my next tutorial in Creo Parametric. In this tutorial, we are going to see how to assemble the gib and cotter joint. In last videos, we have seen how to model a fork, then we have seen a square rod, then we have seen how to model a gib, finally we have seen how to model a cotter. Now, in this tutorial, we are going to see how to assemble this gib and cotter joint by using this orthographic view. We have two views, one is sectional front view and another one is top view. First, we'll assemble this component by using Creo Parametric. For that, just go to the software. Now we are in the Creo Parametric software. For easy assembling, I'm just keeping this file left side, software on the right side. Now, we can see this sketch model also. Now we have modeled all the component. Now we'll assemble by using this one. For that, first go to the new. In last part modeling, we have moved into the part. We have chosen this part 1. Now we need to assemble it. For that, we have to choose this assemble. So design, assemble, then untick this use default template, say OK. Now our units are in mm, so we have to choose mm, ns, assembly, design, absolute. ns, assembly, design, absolute, say OK. Now we are in the assembly module. We'll take the component one by one into the assembly module. We will constrain the components. For that, first go to the assemble. Just click this assemble. First, go for the assemble. Now our first component is fork. So choose this fork. If you want to preview it, just rotate the component and preview it. The second component is square rod. Third one is the gib. And fourth one is the cotter. First, you import the fork. Just select this fork file. Say open. Now fork is came into the software. It has a 6 degree of freedom. We need to arrest these all 6 degree of freedoms. For the first component, you do just go for the automatic. Instead, you choose default. What it will do, it will arrest all the degree of freedom and it will move the component to the local coordinate system. Now here you can see it is fully constrained. Just say OK. Now we have imported the fork. Then we'll import the square rod and assemble into this one. For that, just go to the assemble. Just choose the square rod. Yes, this is the square rod. Just open it. Now the square rod is came into the assembly module. Just translate this component by using this 3 arrow. We can translate it simply. Then by using this circular one, we can rotate the component. Now just simply translate this component to here for easily to give a constraints. Now just see this surface has to be placed with this surface. Both the surface has to be coincident with this here. For that, just select the surface. Here you can see it is taking the first surface as to match with this surface. Both should be in the coincident. So choose here instead of distance, coincident. Now we have made a coincident. Then the top surface has to be coincident with the top surface of the component. That is, we can give, or we can go for the mid plane also. This mid plane has to coincident with this mid plane. That is, we have done. Then this top surface has to coincident with this top surface of this component. Now see, the component is changed into yellow color. That means that it is fully constrained. Just see, if we have 3 constraints we have done, then it has become fully constrained. Then save OK. Now the 7th component also we have assembled into here. Now the third one is we need to place this gib. For that, just import the gib. Just hide this plane. better to view. Now just go to Assemble, select this GIF file. This is the GIF. Just open it. Now GIF is came into our model. Just move your GIF to here. Now we can give us constraints. For that, first here you can see this flat surface has to coincident with the top flat surface. So this surface, this would be coincident. We make it coincident. Then this side surface has to coincident with this side surface. Make it here coincident. And finally, we just want to make this flat surface has to coincident with this surface. Now we have made fully constraint. The component is become yellow means it is fully constrained. Just say OK. Then after that we just want to assemble this cotter. For that just go to here, assemble, choose this fourth component as cotter, just rotate it and check the component, just open it. This is our component. First you just confirm the component to check the color. So this is the longest edge and this is the straight edge surface. So this straight surface has to come this side, so it is in the same direction only. Now just select this file, go for edit. Now switch on the plane also. First you give this flat surface constraint. Select the surface. This surface has to be coincident with this surface. So this is, you make it coincident. Then we switch on the plane. Just hide this all. Switch on this plane. Now it is made confirmed. Just go for edit. Now it has a midplane. So this midplane has to be coincident with this midplane of this object. So we don't have a midplane, so we can give a distance constraint. Just select this surface and move it to downward direction. Just make it to distance. This is in the downward direction. The total, this is the square rod, which is the dimension of 38. So the distance is 38 divided by 2. 38 divided by 2. Then finally we just want to make one more constraint, which is this surface has to coincident with this surface. This is, now it is fully constrained. The distance constraint you just modify a little more here. Just confirm it. This is overlapping, that is because of it is inserted into the component with press bit. So just go for here, just hide all the planes. Now we can go for cut section. Just go for the planar section, switch on any plane, select this one, this plane, say OK. Just hide all the planes. Here you can see, here it is getting overlapped. So thank you for watching my videos. In this tutorial we have learned how to assemble this gibbon cotter joint. In next tutorial we will come up with a new model. Thank you for watching my videos. Thank you.